First of all, draw them. And let's talk about quadrantal angles. 90 degrees is there, it's 180, there's 270, 360. So you should realize this is third quadrant. And actually, it's 180 plus 45. This is exactly down the middle of the third quadrant. And as far as drawing these angles, don't forget the arrow, by the way. You need to make sure it's in the right quadrant. It should be as accurate as possible. So if it's 260, I'd expect you to draw it close to 270. All right, now, so there's the first angle. We're supposed to draw a couple of coterminal angles. All the way around is 360. You can do 360 minus 225. You get 135. So if you go backwards, that angle, that amount of rotation is negative 135. Okay? And then you're supposed to get another positive angle. And let me say again, like I'm going to draw this here, like out here, because I have room here. I'm just trying to indicate how much rotation I'm doing. So that's all the way around is 360, and then 225 more. So if you do 360 plus 225, you get 585 for that angle. And so there you go. There's three angles. Those are all coterminal angles. What I was going to say about drawing this is, if I had room, I'd draw it a little closer in. It doesn't matter. That's another way to draw the same amount of rotation. Don't worry about how big the spiral is. It's how much it rotates around the circle that matters. Now, it's also said identify all angles that are coterminal. So I don't want to see this expression. You say it's a set of all angles, theta, such that the angle is, I'll just use the 225 degrees plus 360k, where k is an integer. A bit about k is an integer. Frankly, as long as it's written down at least once, for like this set of problems, I'm good. It does need to be written down, but you can just define it once. Okay? Do the same thing in radians. And frankly, I'm going to do both of these. Now, let me draw them first. So first of all, pi over 3 is in one quadrant. First, because let me do a little review here. First of all, what is a radian? What is 1 radian? It's how much. What does it mean? It means how much you rotate. So this distance out here, the arc length, equals the radius. That's what a radian is. That's 1, right? So and it turns out it takes pi radians to go half a circle, right? So you're supposed to know pi is 180, 2 pi, 360, and so forth. So your quadrantal angles go like this: half pi, then pi, and then 1.5 pi, which we write as 3 pi over 2, and then 2 pi. So yes, pi over 3 is less than a half, so it falls in there, first quadrant. You should know that. Now, what gets people with radians is, all the way around the circle is 2 pi, always. But how you express 2 pi would change. In other words, here we're talking about thirds, so 2 pi equals how many thirds? 2 times 3 is 6 thirds. So all the way around the circle is 6 thirds pi. I'll come back to this. And over here, all the way around the circle is 2 pi still, but how many radians, how many twelfths is that? 2 times 12 is 24, so 24 twelfths is how you'd express 2 pi here, because you're in twelfths. So, and if I was doing fifths, let's say I had, I don't know, I'll make up an angle, 4 or 5 over 5. 2 pi, if I'm doing fifths, equals how many fifths? See what I'm saying? So you're always adding 2 pi, but how it'll look will depend on your denominator. So back to this. All the way around is 6 thirds, 2 pi, which is 6 thirds. You have 1/3 here, so that leaves 5 thirds for the other part. So you can do 1/3 pi this way, or negative 5/3 pi the other way. There's the coterminal angle. And then if I want to draw another coterminal angle going around this way, in the positive direction, I once again spiral all the way around, and then a third more. There's really 2 ways to express that. You just went 2 pi plus a third. Now, I really don't want to see that, but it's a good starting point. I mean, seriously, do not put this in answer. I wouldn't give you credit for that ugly thing. But 2 thirds is equivalent to how many thirds? So 7 pi over 3. That's how you want to express it. I'm saying, just think of it as 2 pi and a third, 2 and a third, but then write it as an improper fraction. Or we said all the way around is 6 thirds, and 6 thirds plus 1 more is 7 thirds. So somehow or another, you need to come up with the 7/3. So there's your three quadrantal coterminal angles. Coterminal because they end up facing the same direction, right? Now, for the list of all of them, it's the same thing again. It's all angles such that it's, and I'll use the pi over 3 they gave me, plus 2 pi. Okay. Where once again, k is an integer. So the same idea is just 2 pi radians, 360 degrees. Now, I'm going to do the last one. I'm trying to be quick about it. So first of all, negative pi over 12 is a little bit backwards into the fourth quadrant. So you should just draw it like that. And then if you go the other way around, and this is in the positive direction now, you say, okay, all the way around is, we said 24 twelfths. So 24 minus 1 twelfth is 23 twelfths. So that's this one. There's a coterminal angle. Now, we're supposed to come up with an angle that's coterminal in positive and an angle that's coterminal in negative. My point is, I need to come up with another negative angle. So I just go backwards all the way around. And then a 12th more. So that's 2 in the 12th backwards. Would you say 25? Yes. I thought I heard just 5. No. So, yeah, what you said. Well, but my hearing's not that good, so I apologize. My days in the Navy didn't do my ears any good. Seriously, I was young and foolish, and you're supposed to wear hearing protection all the time when you're in the engine room. I didn't, so years later, I'm still paying for it. That's nothing to do with my advancing age. Plus 2 for K. Okay.